Good morning all. Welcome to the next session of vibration measurement. In this session, we are going to study the basic principle and operation of accelerometers. The accelerometer is used to measure the acceleration of a vibrating body. And we know that the accelerometers are known as high frequency instruments. So the natural frequency omega n of this instrument is very high compared to the frequency omega which is to be measured. So the ratio omega by omega, otherwise known as R, is very small. It is smaller than 1. So the range of frequency measurement is shown in this figure. So we know that the vibrometer having a range like this, but the accelerometer having omega by omega n ratio is very less. So the range of accelerometers are here. Since the natural frequency of instrument is high, so it is very light in construction. For studying the principle of accelerometer, again we are considering the equation for forced vibration. So the equation is given us like this, and where here the R is equal to omega by omega n, and we are assuming for accelerometers, we are assuming this ratio omega by omega n is very small. So let's rewrite this equation like this. Z by y is equal to r square into f, where f is equal to 1 by root of 1 minus r square the whole square plus 2 theta r the whole square. And the same, this equation can be elaborated as z by y is equal to omega by omega n square, omega square by omega n square into f. And this can be rewritten as z is equal to y into omega square divided by omega n square into f. And here we know that the omega square is the frequency of the body, that is frequency of vibration of the body, and y is the displacement of the body. So this frequency square into y is nothing but this is the acceleration. This one is the acceleration, and this acceleration we have to find using the instrument. So we can tell that this z is what? Z is the displacement of the seismic mass of the instrument. That is what the output of the instrument. Z is the output of the instrument. So Z will be proportional to y if we assuming that the natural frequency of the instrument is a constant and f is equal to 1. That means the Z, that is the value given by the instrument, is proportional to the acceleration y omega square. So we can use this instrument for measuring the acceleration of the vibrating body. Now we consider the condition for f is equal to 1, when this s will be equal to 1. So let's consider the graph f versus r, or otherwise omega by omega n of different theta values. That is, theta values are ranging from, normally theta values are ranging from 0 to 1. So in this curve, in y-axis we have got f, and x-axis it is r, that is omega by omega n, and we have got different curves with the different theta values. This one is representing theta with 0, and this is the theta with 1. And in this graph, we can see that for a theta value of 0.7, the curve is a straight line. It's a straight line like this. It's a straight line along f is equal to 1. Here f is equal to 1. So it is a straight line along f is equal to 1 up to an r value of around 0.25. So it is seen that for theta is equal to 0.7, there is a complete linearity for accelerometer for omega by omega n less than or equal to 0.25, and it will provide very accurate results. The figure shows the general arrangement of an accelerometer, a seismic type accelerometer. So in which instead of hanging the mass, since it is very lighter in construction, these mass are held like this over the damping pot and the spring. And one more feature is there. Apart from acceleration, it can be used to measure velocity and displacement by employing electronics integration devices. So an accelerometer can be used to measure all the components of a vibration like velocity, displacement, and acceleration. Another type of accelerometer is a piezoelectric accelerometer. So in this, the working principle is same, but for measuring the displacement of this mass, seismic mass, in earlier case we were using an electromagnetic device, but here we are using piezoelectric material. So that is placed under this mass. So by this vibration, this mass has got a displacement in this direction. So because of this displacement, it will exert some force over this piezoelectric material, and this piezoelectric material will produce an electric current, and that electric current is get amplified and used for measuring the acceleration. By this, we are concluding the topic vibration measurement. Thank you for watching and stay safe.